So when adding or subtracting fractions, a very common mistake, even up to grade 12 level, is that, sorry, I'm not sure why it keeps doing that. Good. Yes, recording. A very big mistake is people think, oh, just add the tops together and just add the what? Add the bottoms together. Okay. I can prove to you in a very easy way that that doesn't make sense. Here's the easiest example. Everyone, just eyes actually do it. Since I want this to be on the video, I'm gonna do it on Microsoft Paint. Look, everyone, pencils down. Just focus with what I'm gonna do right now. Paint. Okay. Let's say someone says, I want you to add. Let me minimize this. I want you to add 1/2 plus, sorry, plus 1/2. Okay. And let's say that person says what? Oh, just add, add the tops together and the bottoms together. Okay, you know what? Let's go with this and see where it leads us. Okay, so if we add the tops together, what's 1 plus 1? 2. So that person is claiming 1 plus 1 is 2, and 2 plus 2 is 4. Okay, what did we learn yesterday? You can take any fraction and what? Simplify the numbers. Obviously, 2 and 4 both divide what? Both, both divide 1, and also both divide what? Both divide 2. So that means, does that make sense? No, no, no. The whole thing. That person thinks that if you add half to another half, you get also another what? So that person, so so that person, I'll tell you two ways to really understand why this makes no sense. So hopefully one day you could actually teach someone else. That person thinks that if they're given half of a pizza plus another half of a pizza, how much should they actually have in reality? A whole pizza. Yet, with the math they did tells them that they still have how much? Half of it. Does that make sense? No. Here's another way to understand how completely that doesn't make sense. Those people think that if you have half a dollar, which is how many cents? 50 cents. And another half a dollar, which is another what? We know that 50 cents plus 50 cents should add up to how much? 100 cents, which is one full dollar. Yet that person is claiming they still have half a dollar, which makes no sense. So is the idea of adding the tops and the bottoms correct? No, it's not, because it's leading to what? Completely illogical, senseless answers every single time. Okay, there's got to be another way. And today we learned that other way. So the other way to actually, that was an example, but let's actually finish the example in your notes right here. So in other words, do we just add, subtract the numerators? Which what's the numerator? It's the top part. Denominator is the bottom part. You need to know those two terms. Numerator is the top part of a fraction like 7 or like 19, and denominator is the bottom part, 12 or 4. Okay, in this case. So one of your friends says what? Oh, you want to add these up? Everyone, pencils down. Just focus on here. You want to just add these up? Great. Then just add them up. I'm not sure. Oh, it's good. Just I don't want to start getting concerned, but I hope it doesn't keep doing that. Okay. So they're saying what? Oh, just add it up. You're like, okay. So they say 7 plus 19. Let me zoom in. 7 plus 19 is what? 7 plus 19 is what? 26. And then 12 plus 4, 12 plus 4 is 16. So they are claiming that 7 over 12, whatever that means, plus 19 over 4, whatever that means as well, is somehow going to add up to 26 over 16. Okay? All right. Do you remember yesterday how did we check that our fractions were still correct? What did we say? What was the title? Everyone, what was the title of yesterday? Come on, if you have your notes, simplifying fractions and checking with decimals. You know what? Then let's check that with decimals. Okay. So remember that you can always, I don't usually ask you to do it, but if you want to check on the side, you are more than welcome to use decimal. So you can always check your work by using, treating them as, go ahead, right? Decimals. Okay, so let's actually switch to decimals. What's the first fraction as a decimal? Well, that's why I have. So 7 divided by 12. Okay, is this a finite or an infinite decimal? Yeah, it will never stop what? Okay. It will never stop repeating the threes forever. So you know what? Obviously, we don't have the means of writing an infinite number of threes, but you okay, remember that rounding is always depends on how accurate you want your answer to be. So you know what? For today, let's pick at least one of the three. So I'm going to say 0.583. Go ahead, copy with me. 0.583. Okay. How about the decimal for the second fraction? Okay. 19 over 4. The good news about 19 over 4 is that it's not going to be an infinite decimal. It will stop. Yeah, that's it. Just 4.75. Just 4.75. Okay, so let's add those decimals. All right. 0.583 plus 4.75. How much is that? Well, whatever my trusty machine tells me. Yep, it's 5 point, well, as far as we're concerned, three threes. Okay, so 5.333. Okay, everyone, here's a problem. That is not the same decimal, I guarantee you right now. That is not the same decimal that you will get if you what? If you find out what decimal this number is. Well, you know what? Let's check. The answer we got when we added the fractions, according to your friend, is 26 over 16. As a decimal, that's what? I know it's 1 point something for sure. Yep. So 26 divided by 16 is 1.625. Ends here, no more finite infinite stuff. So 1.625. That is not the same decimal. I'm going to actually put an X in red. Not the same. So what does that mean? Your friend is wrong. Your friend who tells you, oh, just add the tops and add the bottoms, is completely off. 5.333 is not the same as 1.625. So this is not the same as the decimal 5.333. So what did we do wrong? Why? I just added the tops and the bottoms. You never do that when you have what? When you have fractions. So what do you end up doing? How many people here have heard of the phrase, listen up, or the expression, common denominator? If you remember, if you ever remember, doing fractions in grade school, you will know that common denominator was the vehicle that you need to take to add or subtract any fractions in ever in any math course. So what we did do wrong, what is so wrong about doing it this way? You do not, by the way, if adding fractions was as easy as that, then math courses would be like, yeah, okay, fine. Then anyone can teach themselves math. But sadly, there's a little trick to it. Okay, or not sadly, it is what life is, I guess. Nothing sad about that. Just how the universe works. Okay. Yes. Here's the example I just gave you. You do. So I want you to write here, everyone. You do not. You do not. Sorry. You do not just add tops. By the way, I'm a big fan of telling you the big words once, like numerator and denominator, but then just using what? Easy words. And the easy words for today are tops and bottoms. You do not just add tops and bottoms. You do not just add tops and bottoms. Again, 2 over 4 as a decimal is 0.5. That's exactly what we did here, everyone. That's exactly what we did here. 2 over 4 is 0.5. But we know for a fact that half plus half, which simply means 1 half plus 1 half, is definitely 1, not 0.5. The big mistake was, I'm going to do this in green, not, not, let's say, finding, or sorry, using, not using, common, go ahead, write with me, common. Okay, this is a long word, so maybe I should squeeze. Give me 1 second to squeeze. There we go. Oh, I have enough space now for sure. Not using common denominator. There we go. Go ahead. So what we did wrong is that we did not find and use the common denominator. Okay? All right. So today I will teach you how to find. So you must find the common, go ahead, common denominator. You know what? How about we just write common denom for today? It seems that I did not give you enough space to write denominator. Go ahead. Yeah. Well, maybe just I'm writing way too late. So I'm just going to say common denom for today. Okay? So the common denominator is the most important thing that must be there in any problem that involves adding or subtracting fractions. In other words, you cannot do anything until you make the two denominators the same. Go ahead. The same. Well, that's what the word common means. Common means the same. Depending on the original two denominators, finding the common denominator could either be very easy and quick, or could involve what? Could involve a bit of work. However, just remember one very important fact. If you change the denominator of one fraction, you must change the numerator the same way. This is important, and it happens to be one of the common mistakes that people do, is that they don't change the numerator the same way. I'll show you what I mean in a couple of minutes. The same way. So go ahead, everyone. Come on. So you must change the numerator or the top part. You know what? How about you write this under the numerator? Top part the same way. Okay. And everyone, to make your job easier for today and for the future, I actually found a good link for a website that actually helps you always add fractions online. Everyone, look, here it is. We'll use it today to check our answers. Because I'm always a big fan of, if you have a website to use, definitely use it to supplement your learning. Check this out. Everyone, eyes on the screen. This is it. All you have to do, oops, sorry, too much. All you have to do is put the numbers, and even you can choose to do whatever. You can choose to plus, or you can choose to minus, like to add or subtract. So for example, everyone look, let's change this number. Let's change this number to, let's do the one we have in here. What is it? 7 over what? 7. And I think I can go down here. Oh, I have to do tab. Wait a minute. 12. And we're adding, right? Are we adding or subtracting? Like, is it a plus or a minus? Plus, okay, there we go. And what's the next one? 19 over 4. Oh, how many fractions? We only have what? 2 fractions. So everyone, let's change this from 3. Look, it gives you a chance to add 2 fractions. 3, 4, 5, 6, 7, 8. Trust me, I'm not going to ask you to add more than 3. Most of the time, it's only got to be 2. All right. So 2. I have to write again. No problem. 7 over 12. Add 19 over 4. All right. Look, everyone. You just hit calculate. Look at that. It gives you the final answer. 16 over 3. 16 over 3. Well, our job today is do it without using this website. We can just use the website to check. Okay. So let me show you now how to do it. Everyone, look. Let's read the question together. The question says, for the following fractions, everyone, eyes on me. For the following fraction, number 1, find the what? Find the common. If you don't find it, might as well not do the question. Okay. Find the common denominator. Step number 2, change each fraction. Step number 3, add, subtract the what only? The new fraction. Then what? Using what you learned yesterday, if need be. If the numbers are big enough, try to make them smaller. If they're already small enough, just exactly. Use decimals only to what? Don't use them halfway through or in the middle step. Okay, everyone, pencils down. Let me show you how to find common denominator. What's my first denominator? What's my second one? Are they the same? Nope. They're absolutely not. So what do? The easiest way, listen up, the easiest way to find the common denominator, just multiply the 6 by the 3. Seriously, that's it. Just multiply the two numbers together. Okay. So on the side, I want you to write this. I just want you to write 6 times 3 equals what? Anyone? 18. All right. So here's what I want you to do now. And maybe I should have given you some space. So let me give myself some space. Space, space, space. That's it. Okay. Yep, we're good now. So, everyone, the 6 got multiplied by what? By 3. So go ahead, everyone. Write times 3. Like in small handwriting. Go ahead. Times 3. What did I say on the first page? If you change the bottom, you also have to change the what? In the same way. What does that mean? Also multiply the 1 by what? By 3. That's it. Yeah, exactly. How about the next fraction? The 3 got multiplied by what? You got it. So this one is times 6, which means this also has to be what? Okay. Let's now write the what? Let's write the new numbers. Hey. Equals something plus something. Okay, what are my new 4 numbers? What's this number now? What's 1 times 3? I'll do it in a different color. 3. What's this number now? You don't have to guess. The whole idea is that we know it. We created it. Okay. What's this number now? 12. And what's this number now? Do we have a common denominator now? Yes. See, that's the whole point. Somehow, those two numbers had to become the same. Had to become the same. Okay. Now what do? I add. Okay, wait a minute. Everyone, do I add both the tops and the bottoms? Never, never, never. What's the only thing you add? The tops only. Everyone, never touch the bottom. The bottoms stay the same. Ever. That's it. So what's 13? Sorry, 3 plus 12. Easy, no trick. 15 over just how much? Over? Not 36. See, that's the problem. So many people say you have to add those and those. No, 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 no. Okay, as far as I'm concerned, you get full marks for what? Adding fractions. But you're missing one small mark. What is it? What did we do yesterday? No. We did check with decimals yesterday. Simplify and reduce your numbers. Can you tell me what numbers divide 15? Good news. They're small numbers. 1. What else? Come on. 3. It ends in a 5, so it must accept what? 5. You know what? And then 15. Can you tell me? Can you tell me what divides 18? Come on. 18. 1. Interesting. 3, which also worked for what? Keep going with the 18. What else? 3. No, 4 doesn't work. You can try it. 4 doesn't work. 5 doesn't work, remember? Because it ends in 8. 6. We used it. 6. And 9 and 18. What's the common number aside from 1? What was the number that appeared in both lists? 3. Go ahead. Divide by 3 and divide by 3. Divide by 3. Exactly. Because 5 and 6 do not share anything between them. Okay, question. How can you check? Using what? Or I just gave you a website. And the good news about website is you don't have to calculate anything. You just plug the numbers in. Okay, let's do this. What was the first fraction? Yeah. 1/6, so 1/6. And it's a plus. And what was the next one? 2/3. What answer did we get? 5/6. Miles, this will be posted after. Don't worry, like the recording and everything. Don't worry. Okay, if I hit calculate, I better see 5/6 here. I guarantee you that's what's going to happen. Here it is. Everyone, calculate. Life is good. I still have a job. Life is good. Otherwise, I'm BSing you into learning something that's not true. Okay? So please always use this one. Not to do the work, just to check the final answer. Okay? Let's do more so things could check in, could check through. Okay. Everyone, I have a question about this one. Does it have the same denominator? But does it have the same numerator? Do we really care that the numerator is the same? Nope. It's not the numerator we look at. It's the what? The denominator has to be the same. Some people might say, well, they have common numerator. Yeah, common numerator is never a needed, like a necessary thing. It's the denominator that dictates if you can proceed or not. What should I do with the two numbers, 3 and 9? What did I do here with the numbers? Come on, people. Times them. So go ahead. On the side, tell yourself what they should become. So 9, or it doesn't matter, 3 times 9 or 9 times 3, but let's, yes. Thank you. That's the whole idea. 27. All right. Let me give myself some space here. I'll be mindful from now on to always give you some space after before the plus sign. All right. Next. Oh, sorry. 1 second. Come on. Don't do this. No, it's just it always accepts touching. Oh, there. Oh, I know. It's because it's stuck on the text. Okay, you know what? Maybe if I do this, I know what to do. It's this. I just don't like to resort to the keypad. All right. So this one is times what? Times. Which means this also is times. You got it. This one is times. Okay. Equals something plus something. 3 times 9. Yep. 2 times 9. 9 times 3. No. 27. You see? You don't have to guess. It's here. You're being ready to put the same number twice. That's the whole idea. Organization is the name of the game. Stay organized, everything will follow through. 2 times 3. All right. What's 18 plus 6? 4. Divided by what? You never add them. You just keep them as is. 27. Do you think 24 and 27 divide a common number? Actually, they do. Again, we just learned it yesterday, so that's fine. Um, they do divide 1, but as we said, 1 is a useless case. All of them do it. You're actually going to find out that the highest they could go is that they both divide 3. All right, let's take out a 3. So divide by 3. Yep, divide by 3. Divide by 3. That will give you, yep, 8 over 9. Sorry, yeah, 8 over 9. 8 over 9. Do you think you can go lower than 8 over 9? Nope. 8 divides 1 and 2 and 4 and 8. 9 divides 1 and 3 and 9. Sorry, they don't share any common numbers but 1. When they share only 1, you're at the end of the question. You're done, 100%. Let's check. We have 2/3 and 2/9. All right, 2/3 and 2/9. Calculate. We should get 8/9. By the way, you see how, everyone listen up. You see how powerful this website is? It doesn't give you the original, sorry, it doesn't give you this answer first and then simplifies it for you. It goes straight to the what? It goes straight to the what? To the final answer, to the most simplified one. Okay, that's how usually computers do it and calculators. They never give you how it got there. They just show you the finish line. Okay. All right. Sorry. What's happening between those two fractions? Are those being added or subtracted? But guess what? Are we still gonna do the same thing? Yes, I need a common number there. Let's do it. 15 times 5. All right. 15 times 5. I know it. It's 75. Yep. All right. Let's give myself some space. Space. All right. Times 5 times 5 times 15 times 15. Sorry, say again. Yeah, so okay, everyone, look. This one is gonna multiply this one, and this one is gonna multiply this one. And we know that basically one of them is gonna be smaller than the other. So one time the smaller is gonna multiply the bigger, and one time the bigger is gonna multiply the smaller. That's it. Happens every time. So our new fractions are this, and again, everyone, it's different now. It's a minus. All right. 15 and 5, we already have it. We built it up. 75. 7 times 5 is 35. 7 times 5 is 35. Yeah. 1 times 15, well, 1 times any number is the number itself. Okay. What do I do with those two things now? Do I add or subtract? I subtract. Don't add. We added already before. What's 35 minus 15? 20. Over how much? Over 75, because the bottom never ever changes. Do you think 20 and 75 could be simplified? Yeah. I'll give you a hint. One of them ends in a 0 and one of them ends in a 5. What's the common divisor between them? All numbers ending in 0 or 5 divide 5. Yes. So divide 5, divide 5. So that will equal, how much is 20 divided by 5? That is a solid 4. Mhm. And 75 divided by 5 is, and I guarantee you, that's what the website is going to give you as well. Okay, how many problems do I have for you? So we have 12 problems. We've done 3. So I'm going to do 3 more, random 3. We have 12. We've done 3 already. So we have 9 left. So I'm going to do 3 random ones and then leave you the other 6 as your homework, which is already posted as solution. Okay, let's see. Which ones am I mean, it doesn't really matter. They're all the same kind of work. Even if they look difficult, they're not really. Okay, everyone, I'm going to do this one. And I'm going to do, let's do this one. And I'm going to do, oh, did I do addition or subtraction? Okay, one subtraction, one addition. Let's do another subtraction. This one. Sure, let's do this. Okay, so everyone, let's go up here, the second row, middle. Oh, apparently I'm doing the middle one. All right. So, no, yeah, the, the last one, yeah, it's there. Yeah. Okay, what do I do first? Common what? Common denominator. All right. 9 times 15 on the side. How much is 9 times 15? No, no. 9 times 15. That is 135. Again, you don't have to guess. You have calculators here or the cell phone. Please don't guess. You know what's the interesting thing? For some reason, I think it was my grade 11's last term. The calculator is in their hand. So I'm just asking them. I already know the answer. I asked them, and they guessed. I'm like, and they guessed wrong. I'm like, the calculator is in your hand. You're 2 seconds away from giving me the answer. Why are you guessing? He's like, I'm too lazy to type. Are you serious? Like, it's like you can just put it down and even use one hand. Oh, well, whatever. Okay. So, no, 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 not space. All right. So, okay. So 9 times 15, which means also here what? Times what? Yes. Top is the same as the bottom here. Times what? 9 times 9. Let me make this smaller so you don't think it's. Yeah. Okay. New fractions. Something minus something else. 9 times 15. We've already worked it. 135. What's 31 times 15? Okay, give me a second. 50, 465. Oops. Maybe they're looking for something. 31 times 15. Yeah, it's 465. Yep. All right. 19 times 9. 19 times 9. 171. 171. You know what? I'll be honest. No, 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 wait, wait. No, no, wait. This is worth actually talking about. I always do this stuff and I don't say anything. But I know someone's gonna comment. I'm not a genius. I told you so many times. I failed that stuff and I struggled with it all my life. But here's the thing: when you look at someone at this stage, I'm 40. I told you. Always know that whenever you look at someone doing something that you see is amazing, you're looking at the final product. You know that there were nights and weeks and months and years of grit and sweat and crying and failing. Yes. Oh, you have no idea what like it's insane. But here's my point. Here's my point. I have been dealing with numbers in my head since I was in grade 10, 25 years ago. Come on. You've been doing something for 25 years. You gotta be good at it. It's I mean, thank you for the love, but do not yeah, do not be more impressed than thinking that oh he was born smart. Everything comes with practice. And again, by the way, it's not like there are some mental math people who just look at things. This is nothing. They look at like 5 digits times 5 digits and they give you the answer in 2 seconds faster than your fingers can type them in. I have tricks for numbers like within the 20s, hundreds, but again, I've already developed tricks. That's all. So it's 171 over what? Over 135. Okay? Equals 135. Also, when you do, like when you have been teaching math and physics for as long as I have, you always know how to approximate things. So even if you didn't get it exact, you're close enough. Okay, what's 4065? Sorry, 465 minus 171. You know what? I usually, when I do things like this in my head, I just do it the old grade school way. I go, okay, 465 minus 171. 5 minus 1 is 4. Yeah, uh, trust me. Basic ways still work. Now, 6, can you do 6 minus 7? No, you can't. So you steal 1 and you carry the 1. So it's 16 minus 7, that's a 9. And this goes down to a 3, so it's 294. Again, I am doing this. You do not have to do it in your head. Okay? You're more than welcome to, but there's no need. Okay? So 294 over 135. Oh, this is, are those numbers small or big? Kind of big. Okay, you know what? Um, no, no, wait. You know what? We can do it on the website right now. And if it gives us that, that means what? It's not simplifiable anyway. So we're fine. However, what's up? No, no, sorry, what's 400? No, 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 no. I'm already done. Hamid, I've already subtracted. I am just thinking, can I simplify those numbers? That's all. I don't really think so. You know why? Uh, this one, this one doesn't divide 2, or 3, or 4. It divides 5, but this one doesn't divide 5. You know what? Let's just check the website and see what it says. I mean, if we have enough time, we can get through it. But sometimes you not only don't have the time, maybe you're just not interested. Okay, what are the values? Come on, Jalil, what do we have for the one we just finished? I just want to check if our final answer is as simplified as it is. What? The one, the one we just finished. Yeah, right. 31. Wait, 1 second. 31 over 9. Is it a minus or a plus? It's a minus, so watch out. What's the next fraction? 19. Wait, what? 19 over 15. Okay, let's see if. Oh, so what? Wait, really? No, no, no. So did I miss something? Oh, my bad. I said this one. Oh, they both divide 3. My bad. Remember that. Remember the trick with adding up the digits? Yeah, let's quick. Let's add up the digits, everyone. What's 2 plus 9? Come on. 11. And what's 11 plus 4? 15. 15 divides 3. Okay. What's 1 plus 3? 4 plus 5. 9 divides 3. Yeah, I should have actually said they do divide 3. So divide by 3. Divide by 3. So I don't know how I missed it before. Equals. Apparently we know the answer from the website. It's 98 over 45. Done. It has to be. Otherwise, the website would have given you even smaller numbers. Great. Okay. Let's do the next one. Go ahead. You can start. I mean, yeah, you do have the rest as homework, but you can do this one. This one. Okay. 8 times 14. All right. 8 times 14. Now, how much is 8 times 14? Well, 14 times 14. Oh, yes, sir. Yeah, 112. Okay. So, oh, I need some space. Okay. So this will multiply 14. Okay. And this will multiply 14. This will multiply 8. And this will multiply 8. Okay. Let's keep going. Something plus something. What's 8 times 14? No guesses. We just invented it. Now, what's 19 times 14? Well, 14 times 20 is 280. Sorry. Yeah. 266. 266. 19 times 14, 266. Okay. What's 13 times 8? 104. Divided by, obviously, the same 112. Okay. Let's add up. 112 stays the same. Now, what's 266 plus 104? If you do it with vertical addition, like they taught you in grade school, you get exactly 370. Everyone, 370. What do you think 370 and 112 both divide together? I'll give you a hint. They're both even numbers. What do all even numbers divide? 2. They're all divisible by 2. So let's take a 2 down. All right. By the way, they probably divide something higher than 2. I just can't see it yet. So I'm just going to take it slow. Divide by 2. And divide by 2. Okay. What's the next step? What's 370 divided by 2? Well, 185. You got it. And 112 divided by 2 is, wait, oh, sorry, 56. Yep, 56. Okay. Now, what does, by the way, always try to look at the smaller number first. Which one is the smaller number? Okay, everyone, let's look at 56. By the way, don't copy this. Up to just copy up to here. Do not copy what I'm about to do. Okay, this is just like extra work, just to see if the number could go further down. What does 56 divide? Well, I know it divides 1. I know it divides 2. I know it doesn't divide 3. I know it divides 4. Does it divide 4? Yes, it does. I know it doesn't divide 5 or 6. It does divide 7 and 8, because 7 times 8 is 56. Uh, no, not 31. No. Again, you can try 31. It's gonna give you a decimal. No 9, no 10, no 11, no 12, 28. Gotta put it here. I know it divides 14 for sure. I know it divides 56, of course. So let's see. 1 times 56. 2 divided 28. 4 times 14. That's it. That's it. Let's see if any of those numbers, everyone, let's see if any of those numbers work for what? 185. Well, guess what? I can right off the bat tell you that none of the even numbers is going to work. 2 is not going to work. 4 is not going to work. So look, everyone, I know that 2 is not going to work. 4 is not going to work. 8 is not going to work. 14 is not going to work. 28 is not going to work. 56 is not going to work. What's the only thing I can try? What? 7. Okay. And again, there is no guarantee. 185 divided by 7. Oh, so that means what? Are we at the end of our solution? Yes, we are. Apparently, no numbers are divisible. Okay, that's fine. So I'm just going to erase all of it. So that is your final answer. And now, if I actually check it, so what is it? Oops, sorry. 19 over 8, 13 over 14. 19 over 8. It's a plus. So how much is it? 13 over. Oh, no. Sorry, sorry. 15 over 14. Yeah. Okay. Oh, 13. Okay. Okay. Whoa. Oh. 150, 185 over 56. Is that what we got? So that means what? That's as small as we can get the number. All right, last one. Last one. Hey, I have the same number on top. Yeah, that does not help me in any way. What helps me is if the same number is at the bottom, which is always what we need to do. Okay, I'll give myself space. Um, 6, 6, 6 times 10. How much is 6 times 10? 60. All right. So 6 times 10, 7 times 10, 10 times 6, right? Yes, 7 times 6. Okay, couple of new fractions. 70 over 60. What's 7 times 6? Anyone? I know it. 7, 40, 2, 60. Okay. Hey, the number's not going to be as big as the other ones, so it's going to be good. Now, what's 70 minus 42? 70, take away 42. That's exactly 28 over 60. What numbers do 28 and 60 divide? Well, they both divide 1. They're both even numbers. They're both even numbers. So they both divide what? They both divide what? 2. Guess what? If you keep writing the lists, you're going to find out that they also divide 4. But let's say you didn't see that. Seriously, because sometimes you're like, I'll just get it in steps. Okay, you know what? Let's do that. So let's divide by 2, everyone. And let's divide by 2. Knowing that's not going to be enough, but we're going to keep going. Equals. What's 28 divided by 2? 14. What's 60 divided by 2? Uh, that's multiplication. What did we end up with? 14 and 30. Another 2 even numbers. Guess what? There you go. Go again with 2. Divide by 2. Divide by 2. Sometimes you have to do that. So what do we get? 7 over 15. And guess what? Check. That's it. No way it's going to go any smaller than that. Okay? So that's how you add or subtract fractions. Sorry. That's how you add or subtract fractions. The name of the game, the key step, common denominator. Also, another key step, never do anything. Everyone, look, never do anything to the denominators at like towards the end. 60, you don't say 60 minus 60, or you don't do like something like a denominator. No, you make them equal, and then they stay the same the whole time, unless you're trying to simplify it. Okay? And that's it for adding or subtracting. Now you know as much as grade 12 students know about exactly how to, no matter how weird the numbers look, you just need to figure out the common denominator. The hardest step is this, simplifying. Doing Finding the common denominator doesn't take much. You just multiply those two together. It's getting your numbers to be smaller is always going to be the extra work. However, I'm not going to give you questions where you have to do a lot of guessing like this one. Sorry, not like this one. Actually, this one was good. Like this one. This one even stumped me. I didn't know what it shouldn't have stumped me, but it did. So I definitely see it from your perspective as well. Okay? And that's it for today's lesson.